Compute the integral from 0 to 1 of x cubed multiplied by x squared minus 1, all of that to the fourth. So this seems to be u sub, but there's going to be a little bit more to it. So let's just get into it. So writing our integral here. So let's say our u, because it's this quantity raised to the fourth, we have our u is equal to x minus 1. And our du equals to 2x, right? So we have that, but we have another x squared left over. Because if we were to write this like this, multiplied by x squared, then we would have our u to the fourth and our dx. So we know that we need to take out at least a 1/2. So that would be like this, and we have 2x. But then we have an x squared left over. Well, thankfully, we can actually manipulate our u to make it a u plus 1 is equal to x squared. So now we have all of our terms in terms of u, then we just sub those in. So then we get the integral from 0 to 1, and then our 2x is going to already be taken out, so that's a 1/2. Then our x squared is going to become u plus 1, and then we already have our u to the fourth, that is du. So now what's next? Now we distribute. So we have u to the fifth plus u to the fourth du, and so I didn't want to do this until now, but these limits are actually not right. These limits are not right if we're in terms of u. So we have to plug in these limits of 1 and 0 into our formula for u, and then we'll get the proper limits of integration. Because you could find the antiderivative and then plug in your u back into terms of x, but that makes it a lot more complicated. So 0, if you plug it into our u, we get -1. If we plug in 1, we get 0. So now we just solve this integral, which is pretty easy. So if I bring it over here, so now we have u to the 6 over 6 plus u to the 5 over 5 evaluated from -1 to 0. So let's just plug those in. So 0 over 6 plus 0 over 5, that's going to be 0. We're going to minus -1. So since 6 is an even exponent, then this is going to become a positive 1. So 1 over 6. And then since 5 is an odd, then this is going to become -1. So we can say minus 1 over 5. And so now we can just simplify that, which it'll become, I think, 5 over 30 minus 6 over 30, which is going to be -1 over 30 multiplied by negative, and we get 1 over 30. And we got to remember we have this 1/2 over here, so it can be still all this multiplied by 1/2, and that's going to equal 1 over 60. So there we go. That is our answer, which is going to be A. Compute the integral of cosine to the fourth multiplied by sine to the fifth. Now looking at these answer choices, you may be inclined to think it is integration by parts, and while maybe you could use integration by parts to solve it, that'll just take forever. And if you're to use the table method shown earlier, you can see that no matter whether this first function or the second function is your derivative column, those will never hit 0 because the derivative of cosine is 4 cosine negative sine, and then you would have to product rule that, and then it would become huge, and it would still never ever hit 0. So we not got to use u sub. Go to u sub and a little bit of trig identities. So let's get started. So cosine to the fourth of x, sine to the fifth of x, dx. So we know, so let's start off with having our u be assigned to cosine of x, just normal cosine. Then our du is going to be negative sine of x dx. So that's all fine and well, but we run into a problem. So if we say all of our u's are cosine, so we have u to the fourth multiplied by, and we have a negative cosine, so we can take out a negative, and then we have sine to the fourth still of x, and then we have our du. So what do we do? Well, if we recall that sine squared is equal to, one of the easiest trig identities, remember, is equal to cosine squared, then this becomes super easy. Because if we were to square both sides of these, then you get, this would be sine to the fourth, and what do we have here? Sine to the fourth. So we have u to the fourth multiplied by 1 minus cosine squared raised to the 2, or the squared. So it's a negative, and now we have our du, and our cosine is a u, so we get 1 minus u squared squared u to the fourth du, and then we have our negative. And so now we can solve. So first let's distribute, or I forgot what the name is, but FOIL, you know, because we know a plus b is squared equal to a squared plus 2ab plus b squared. So we're going to have u to the fourth multiplied by, so a squared will be 1 plus 2ab, so it will be minus 2u squared, and then plus u to the fourth du. And we just distribute. We have u to the fourth minus 2u to the sixth plus u to the 8th. Integral negative du. And so this is fairly simple to solve. Let's bring this up here. And our antiderivatives will be u to the fifth over 5 minus 2 u to the 7 over 7, and then plus u to the 9 over 9. And then we all have the negative, so we gotta multiply the negative plus, this becomes a negative, and so now, and our plus c. And then there we go, that was our answer. But we have to plug in our u, and so we get negative 1/5 cosine to the fifth of x plus 2 over 7 cosine to the 7th of x, and then minus 1 over 9 cosine to the 9th of x plus c. Of course, always remember your plus c. So now let's check our answer choices. Negative 1/5 plus 2 over 7 minus 1 over 9 plus c seems to be d. So pretty simple. Just gotta remember your trig identity, and yeah. Find the area bounded by y equals e to the x, y equals e to the negative x, between 0 and 1. So, with these problems, it's nice to make a drawing. So, it's going to be our e to the x, it's a exponential, and e to the negative x, which is going to kind of like reflect it and look like that. So, there we go, and we're trying to find the area between 1, let's say this is 1, and 0. This area right here. Maybe I should have made it a little bit bigger, but who cares? So, let's start. So, this is just a simple area problem, so it's going to be the area of this first graph minus the area of the second graph, because you could say e to the x is our say e to our x is our top graph. It's a little weird to think about it like that. I mean, that's kind of a rule of thumb. It's not always correct, but you can just think about it like that. So, and we see these don't overlap past 0, so we know that we only need to use one integral. So, this is pretty simple. And we find our antiderivatives, e to the x, and the antiderivative of e to the negative x is going to be negative e to the negative x, because you derive it and stuff, and yeah. Oh, sorry, no plus c. This is a definite integral. So we're evaluating this from 1 to 0. So we can write this actually as e plus e to the negative x from 0 to 1. So we get e, so I'm gonna write this as a fraction in the evaluation. So we get e to the 1, which is e, plus 1 over e to the 1, which is 1 over e. And we subtract e to the 0, which is 1, plus 1 over 1, which is e to the 0, and then we get 2. So this is going to be e plus 1 over e minus 2. And this will be our answer. And that answer choice will be A. How nice. Which of the following represents the volume of the region bounded by the curves y equals 6x minus x squared and the x-axis being rotated about x equals negative 1? So let's start off with a graphical representation right here. So to find the x-intercept of our first curve, 6x minus x squared, that can be factored as, take out x, 6 minus x. So steps are here, and let's say this is 6, and it's going to be a negative quadratic, so it's going to be something like this. So on the x-axis, so the area we're rotating is this, right there. And we're rotating it about the line y equals negative 1. So we can say that's like about here or something. Or sorry, x equals negative 1. I keep saying y. So how are we going to approach this? So the method it seems the answer choices want us to use is the shell method. So the shell method is basically like we take a little sliver of this graph right here, of this area that we're trying to rotate, and then we're rotating it about using 2 pi. So rotating it about like there, and then we do that for each little sliver, and then we get an actual volume of a shape rotated about that point. And so the actual method behind shell method is a little bit complicated, but the way I like to think about it is, so we have our integral, and our bounds are going to be 0 and 6, because that is the x-intercepts. And so the way I like to think about it, so this one is pretty easy, because the actual volume or the actual area we're trying to rotate is just simply 6x minus x squared, because it's bounded by the x-axis, so there's nothing extra we need to do. And then the way I like to think about it is, so if you're to just normally do this multiplied by 2 pi, then this would just be the area rotated about the y-axis, right? But we're shifting it 1 to the left. So we need to account for that and say, for every x, we gotta shift that over 1. So, and that would be plus 1 dx. So that's the way I like to think about it, because it just basically makes it simply, so if x was 1, it would be x minus 1, but since we have a negative, it's x plus 1. And so this would be our answer, because we're rotating each little sliver rotating each sliver of this area right here, we're rotating it about a line plus 1 over. And so yeah, so that would be our answer. And that answer would be E. Yes. Compute the integral of cosine cubed 2x dx. So initially you might think to use a trig identity, because we have a 2x and that's double angle, but looking at the answer choices, they don't want us to do that, and they just want us to keep it as our 2x, which is a lot easier. But the question is, how do we solve this integral? And so maybe we have cosine cubed, so cosine cubed can be broken down into cosine squared, multiplied by cosine of 2x, and you know, we know that cosine squared is equal to 1 minus sine squared. So we can actually rewrite this as 1 minus sine squared of 2x multiplied by cosine of 2x. So would you look at that? We have sine and cosine, and those happen to be derivatives of each other, so we can use u sub. So if our u is sine of 2x, then our du is equal to cosine of 2x. Now we're taking the derivative, so we gotta multiply by this 2. We have 2 cosine 2x. So that makes everything so much more simpler. So we take out a 1/2 to account for our cosine 2x, and then we have 1 minus u squared du. And now we just integrate this, or antiderive it, and we get u minus u cubed over 3, all that multiplied by 1/2, plus c. And so if we plug in back our stuff, we get 1/2 sine of 2x minus 1 over 6 sine cubed of 2x plus c. And there is our answer. And so that would be E. I think the problem with this one is you got to remember this is 2x, because often people just say it's x, and they would think our du is just cosine, but that's not the case, because you got to use the composite derivative rule. I forgot what it's called. Chain rule. You got to use chain rule. A cable